The Boeing 767 pneumatic system is comprised of pneumatic ducting and isolation valves that interconnect the pneumatic sources with the using systems. The pneumatic sources are the engine bleed air, the APU bleed air, and external compressed air. The using systems include the air conditioning system, wing and engine anti-icing, engine starting, air-driven pump, and hydraulic reservoir pressurization. The pneumatic system is divided into a left duct, a center duct, and a right duct. There are left, center, and right isolation valves that are used to control the flow of bleed air. These isolation valves are motor-operated valves. When the engines are running, the left and right isolation valves are normally closed, and the center isolation valve is normally open. On the ground, when the engines are off, all three isolation valves are normally open. Switches on the bleed air control panel operate the APU and engine bleed air supply valves and the isolation valves. The bleed air systems of the two engines are identical. Engine bleed air is supplied by either the high pressure, HP, or low pressure, LP, engine compressor. High pressure bleed air is automatically provided during low engine thrust settings. At high power settings, the low pressure compressor supplies the bleed air, and high pressure air is not required. How does this work? Well, during low engine thrust operations, the high pressure valve is open, allowing high pressure bleed air into the pneumatic system. As thrust is increased, the high pressure valve automatically closes and the low pressure bleed air check valve opens to supply pneumatic bleed air. Bleed valves are used to turn on or off the supply of engine bleed air to the respective manifold. The bleed valves are electrically controlled and pneumatically operated. Therefore, the valves not only require an electrical signal to open, but also require air pressure. The on position of the switch provides the signal to open the valves. The on position is indicated by a displayed flow bar in the switch and is the normal position of the switch. With the bleed air switch on, the bleed valve opens when sufficient bleed air pressure is available to the valve, provided there is a demand for engine bleed air. Example, the air conditioning packs are on. The bleed switches normally remain in the on position. However, the off light illuminates in the switch until sufficient bleed air pressure is available from the engine to open the valve. This indication is normal before engine start. Immediately after engines start, but before the packs are selected to auto, the off lights remain illuminated until the air conditioning packs are switched to auto. Therefore, it is normal for the bleed valves to not open until there is a demand for engine bleed air. As we complete the discussion on engine bleed air, let's identify the flow of engine bleed air to the anti-ice systems. Note that engine anti-icing bleed air is available without the engine bleed air valve open. On the other hand, wing anti-icing bleed air is not available without an open engine bleed valve, and then only to the respective side unless the isolation valves are open. APU bleed air is available on the ground and in flight. On the ground, it is used primarily for air conditioning and for engine starting. In flight, APU bleed air is available up to approximately 17,000 feet. The APU bleed air is connected to the center manifold through the APU bleed valve. The APU bleed valve is electrically powered and depends on system logic for operation. The APU bleed air switch is normally in the on position with the flow bar in view. After APU start, if the engine bleed air is not supplying the system, the APU bleed valve will open. As the APU bleed valve opens, the valve light in the switch illuminates while the valve is in transit. After the first engine starts, the position of the APU bleed valve is dependent on system logic. You may notice that the APU bleed valve normally remains open at this point. After both engines are started and are delivering sufficient bleed air pressure, the APU bleed valve normally closes. Opening or closing the APU bleed valve is indicated by momentary illumination of the valve light in the APU bleed switch. When the valve light is illuminated, the APU bleed valve is not in the logic commanded position, which normally means the valve is in transit. Remember, the APU bleed air switch normally remains in the on position. However, if the APU is operating and the APU bleed air switch is selected to off, the valve light will cycle to indicate the momentary disagreement between switch position and the valve. Likewise, if the APU is operating and the APU bleed air switch is selected to on, the valve light will cycle when the APU valve moves to the open position. To review, the operation of the APU bleed air valve depends on the engine bleed air valves. With no engine bleed air available after APU start, the APU bleed air valve will open when the APU reaches normal operating speed. The APU bleed air is supplied to the center manifold. With the center isolation valve open, air also flows up to the left and right isolation valves. Further flow of APU air is dependent on the position of the left and right isolation valves. Normally, all three isolation valve switches are selected to on when the aircraft is parked at the gate. This configuration allows APU air to deliver to the packs or engine starters. Once the engines are operating to provide bleed air and the APU bleed air is no longer required, the APU bleed valve closes automatically. You will see the valve light illuminate momentarily. After the engines are started, the left and right isolation switches are normally turned off by the crew, since the APU air is not necessary to operate the packs. The center isolation switch normally remains on.
One final note. After engine start, if the engine anti-ice is turned on, you may have less engine bleed pressure available than APU bleed pressure. In this case, you may notice the engine bleed valves remain closed until the engines are spooled up for taxi. Upon engine spool up, the APU bleed valve closes and the engine bleed valves open. This scenario is natural and is not a cause for concern.
Two connectors are available on the left pneumatic duct to connect high-pressure ground air sources directly to the bleed air ducts. The connectors incorporate check valves to prevent reverse airflow from the bleed air ducts to the ground source. Two connections are recommended for dual air conditioning pack operation or engine start. Opening the right isolation valve allows the ground pneumatic air to also supply to the right duct. Engine or APU bleed air or ground pneumatic air is distributed through the bleed air duct system to the user components. A duct pressure indicator displays the pressure in the left and right pneumatic ducts with two pointers labeled left and right. Each engine normally supplies bleed air to its respective pneumatic duct. Both engines supply air to the center duct. The delivery of engine bleed air to the center duct is provided through check valves. The check valves restrict air movement from the center duct into the left or right duct unless the associated isolation valve is open. Therefore, a cross flow of air from one engine cannot normally occur with the left and right isolation valves closed. The center isolation valve is controlled by the guarded center isolation switch. The switch for this valve is normally in the on position to allow engine bleed air to flow to the components of the center system.
On the other hand, when the APU bleed air is in use, the open center isolation valve allows the APU air to deliver to the center duct. Once the APU air is in the center duct, it can be routed through the opened left and right isolation valves to the left and right ducts for operation of air conditioning or for engine starting.
To review, before engine start, the left and right isolation valves are normally open and the center isolation valve is open. This allows APU air to deliver to both engine starters and packs. After engine start, the crew will normally close the left and right isolation valves. This allows each engine to feed the respective pneumatic duct and the center duct.